My dear students, Namaste, good morning to you all, and also welcome to another session of our mathematics class. In the previous session, we have discussed question number 1 to 12 from exercise 10.3. Hope you have revised well. In today's session, we shall discuss the remaining problems from exercise 10.3 and also will discuss the cross product of two vectors. Let's move on to the topic. Next, we shall discuss question number 13 from exercise 10.3. The question is, if vector A, vector B, vector C are unit vectors such that vector A plus vector B plus vector C is equal to 0, find the value of vector A dot vector B plus vector B dot vector C plus vector C dot vector A. Here, there is no formula for finding this A dot B plus B dot C plus C dot A direct formula. So, we have already learned an algebraic expression, that is A plus B plus C the whole square expansion contains this term. A plus B plus C the whole square is A square plus B square plus 2AB plus 2BC plus 2CA. Here, if you take a 2 common, this term will be coming AB plus BC plus CA. Only thing is that we have to use vector notation. And we have to begin with a statement we have already learned in vectors, that is vector A dot vector A is equal to modulus of vector A square. By using that, we can write modulus of vector A plus B plus C the whole square is equal to, because we need A, B and C. So we can take modulus of A plus B plus C the whole square is equal to vector A plus vector B plus vector C dot vector A plus vector B plus vector C. So here, just like A plus B plus C the whole square expansion, we can expand it this one. A dot A, then B dot B, then C dot C. So that is A dot A we have already learned, modulus of A square plus modulus of B square plus modulus of vector C square plus 2 we have to take common, then 2 into A dot B plus B dot C plus C dot A. By using the given condition A plus B plus C, we know that it is 0. So modulus of A plus B plus C is also 0, is equal to, they are unit vectors. A, B and C are unit vectors. So modulus of A is 1, modulus of B is 1, modulus of C is 1. Similarly, modulus of A square also 1, modulus of B square and C square also 1. So if you put 1 plus 1 plus 1 plus 2 into this term as it is, A dot B plus B dot C plus C dot A. That is equal to, directly we can write A dot B plus B dot C plus C dot A is equal to 1 plus 1 plus 1, that is 3. That 3, when it goes to the left side, it becomes minus 3 divided by these 2. So minus 3 by 2 is the answer. Move on to question number 14. The question is, if either vector A is equal to 0 vector or vector B is equal to 0 vector, then vector A dot vector B is equal to 0. But the converse need not be true. Justify your answer with an example. Here there is a statement is given to you. The statement is like this: vector A is equal to 0 vector or vector B is equal to 0 vector. Then their dot product must be 0. The converse we have to prove that need not be true. Means converse means reverse order. If vector A dot vector B is 0 means vector A is equal to 0 vector or vector B is equal to 0 vector. That statement we have to check whether they are true or not. Once again, if vector A dot vector B is equal to 0 means we have to check whether vector A is equal to 0 vector or vector B is equal to 0 vector. Here we have to take two vectors A and B. Vector taking time we have to be careful because we need to get their dot product 0. So little bit of logic we have to take. We have to use. First of all, we have to take A vector, that is vector A is equal to 2i plus 4j plus 3k. Any vector you can take. Any vector of your choice we can take. But when you write vector B, you must be little bit of careful because when you multiply the components, scalar components, we should get 0. Here vector A 2i cap plus 4j cap plus 3k cap. And vector B I have taken 3i cap plus 3j cap. We have to stop here, then we have to check 2 into 3, that is 6, again 4 into 3, that is 12, 6 plus 12 is 18. So we want to get dot product 0 in the sense next term should be minus 18, because 18 minus 18 is 0. To get minus 18, here already 3 is there, means we have to get 6 here, minus 6, so as component, so minus 6k. When you multiply it 6 and 3, 18, here there is a minus sign, minus 18 will come, so the dot product will be 0. That is the way we have to go, little bit of adjustment when you take vector A and vector B. Then let's take vector A dot vector B, that is equal to A dot B in the sense 2 into 3 plus 4 into 3 plus 3 into minus 6. So 3 into 2 is 6, then 4 into 3 12, 3 into minus 6 is minus 18, 6 plus 12 is 18, 18 minus 18 is 0. So A dot B we have got 0. Next we have to verify whether vector A is equal to 0 vector or vector B is equal to 0 vector. It's quite simple. Let's take the modulus first. Modulus of vector A is root of x square plus y square plus z square, that is 2 square plus 4 square plus 3 square. That is, when we get it, when we add it, that is 4 plus 16 plus 9, we will get as root of 29. So modulus of vector A is root 29. It is a scalar quantity which is not equal to 0. So modulus of A is not a 0 vector because the modulus or the magnitude x is there, so it is not a 0 vector. Then again vector B modulus we have to take, that is equal to x square plus y square plus z square, that is 3 square plus 3 square plus minus 6 whole square. When you add it, we will get as root 54. This also a non-zero quantity, therefore we can conclude that vector B is not a 0 vector. So here A dot B we have got 0, but A is not a 0 vector, B is also not a 0 vector, means the converse of the statement need not be true. That is our conclusion. Next we shall discuss question number 15. If the vertices A, B, C of a triangle ABC are 1, 2, 3, minus 1, 0, 0, 0, 1, 2 respectively, then find angle ABC. There is a hint is given. Angle ABC is the angle between the vectors BA and BC. Of course, here when it is asked in the examination, the hints will not be given, so we have to find out from the given angle itself. It is quite clear, B is in between A and C, so the angle B is in between the vectors BA and BC. So here by using the dot product formula, that is vector A dot vector B is equal to modulus of vector A into modulus of vector B into cos theta. By using that formula, we can find out the value of the required angle. For that, first of all, we have to calculate vector BA. BA, we know that second point minus the first point, that is here 1 minus minus 1. Here BA is the angle, BA is the vector, means A minus B. Point the coordinates of A minus the coordinates of B, that is what we have to do. Coordinates of A here is 1, 2 and 3. So 1 minus minus 1 into I, then plus 2 minus 0 into J, plus 3 minus 0 into K. When you do the calculation, it is 1 minus minus 1 is 2. So 2I plus 2J plus 3K, that is BA we have got. Next we have to go for calculating vector BC. Vector BC, as I said before, it is C minus B. Here point C is this one, minus B is this one. So 0 minus minus 1, 0 minus minus 1 into I, then plus 1 minus 0 into J, then plus 2 minus 0 into K. When you do the calculation, it is minus 0 minus minus 1. 0 minus minus 1 is plus 1. So plus 1 into I is I, then 1 minus 0 is 1, that is 1 into J is J, then 2 minus 0 is 2, 2 into K is K cap. So I plus J plus 2K. So that is BC. Next we have to go for BA dot BC. So BA dot BC is equal to, we have the vectors, we have to write it in order, that is BA is 2I plus 2J plus 3K dot I plus J plus 2K. We already learned that how to find out the dot product of two vectors which are in component form. Just to multiply the component, that is 2 into 1 here plus 2 into 1 again plus 3 into 2. So that is equal to 2 into 1 is 2, 2 plus again 2 into 1 is 2, again 3 into 2 is 6. So 2 plus 2 plus 6. That is equal to 6 plus 4 equal to 10. That is BA dot BC. Then again we have to go for modulus of BA, that is equal to root of x square plus y square plus z square, that is 2 square plus 2 square plus 3 square. that is equal to root of 2 square is 4, again 2 square is 4, again 3 square is 9. So 4 plus 9 we will get as a root 17. Next, modulus of BC. Modulus of BC is x square plus y square plus z square, that is 1 square is 1 square plus 1 square plus 2 square. So 1 square is 1, again 1 square is 1 plus 2 square, that is equal to root of 1 plus 1 is 2, 2 plus 4 is 6. Now let's use the dot product formula, that is BA dot BC is equal to modulus of BA into modulus of BC into cos of the particular angle between BA and BC, that is angle ABC. That is BA dot BC we have already calculated, that is 10. 10 is equal to vector modulus of vector BA is root of 17 and modulus of vector BC is root of 6. So root of 17 into root of 6 into cos of angle ABC. From here cos of angle ABC we can calculate, left side there is 10 divided by these two quantities, root 17 into root 6, that is 10 divided by root 17 into root 6. That is angle ABC is equal to cos inverse 10 divided by root 17 into root 6 is root of 102. So the angle we have got here is cos inverse 10 divided by root of 102. Next we shall discuss question number 16. The question is, show that the points A127, P263 and C310 minus 1 are collinear. Collinear means we have to prove that the 3 points are lying in a same straight line. For that, first of all we have to write vector AB, then vector BC, then vector AC or CA we have to write. Then we have to go for calculating the magnitude of vector AB, then magnitude of vector BC, then magnitude of vector AC or CA. Then we have to prove that magnitude of vector AB plus magnitude of vector BC is equal to magnitude of vector AC. If that statement is true, then we can say that A, B and C are collinear. So this question you will do it as homework. Question number 17. Show that the vectors 2i cap minus j cap plus k cap, I cap minus 3j cap minus 5k cap, 3i cap minus 4j cap minus 4k cap form the vertices of a right angle triangle. So here 3 position vectors are given to you. Let's take these vectors are OA. Position vector of A is equal to 2i cap minus j cap plus k cap. Then OB, position vector of B is equal to I cap minus 3j cap minus 5k cap. And OC is equal to 3i minus 4j minus 4k. From here let's calculate vector AB. Vector AB means position vector of B minus position vector of A. So here the scalar component of I is 1 minus 2. So 1 minus 2 into I cap plus here minus 3 minus 1. Minus 1 is plus 1. So minus 3 plus 1 into j cap. Then plus minus 5 minus 1. So minus 5 minus 1 into k cap. When you do the calculation we will get as minus I cap minus 2j cap minus 6k cap. Then we have to go for BC. Vector BC is equal to position vector of C minus position vector of B. Here 3 minus 1 into I, then minus 4 minus 3. So minus 4 plus 3 into j cap, then plus minus 4 minus 5. So minus 4 plus 5 into k cap. When you do the calculation you will get as 2i minus j, then here plus k. So 2i minus j plus k cap. Then we have to go for CA. Vector CA we have to calculate. Vector CA is position vector of A minus position vector of C. So A minus C. 2 minus 3 into I cap minus 1 minus 4. That is minus 1 plus 4 into j cap. Then 1 minus 4. 1 minus 4 is 1 plus 4 into k cap. So when you do the calculation we will get as here 2 minus 3 is minus 1 I cap. Then minus 1 plus 4 is 3 j cap. Then 1 plus 4 is 5 k cap. Then from here we have to calculate modulus of AB, modulus of BC and modulus of CA. And this part we have done before and we know that how to prove these position vectors, or how to prove this AB, BC and CA forms the sides of a right angle triangle. Means we have to verify the Pythagoras statement. So that part you will do it as homework. Next we shall discuss question number 18. The question is, if vector A is a non-zero vector of magnitude A and lambda a non-zero scalar, then lambda into vector A is a unit vector if Four options are given to you. Lambda is equal to 1, lambda is equal to minus 1, a is equal to modulus of lambda, and a is equal to 1 by modulus of lambda. Here the given conditions we have to check. Vector a is a non-zero vector of magnitude a and lambda a non-zero scalar. So magnitude of vector a is given to you, that is a. And here one more condition is given. Lambda vector a is a unit vector. So that condition we can take. Unit vector in the sense the magnitude is 1. So lambda into vector a, modulus of lambda vector a is equal to 1. We can split this one. Modulus of lambda into modulus of vector a is equal to 1. From here modulus of vector a is equal to 1 divided by modulus of lambda. This modulus of lambda will come as denominator here. So modulus of vector a, it is given to you here. Vector a is a non-zero vector of magnitude a. So modulus of vector a, we can write it as a is equal to 1 divided by lambda. So the correct option here is option D, that is a is equal to 1 divided by modulus of lambda. In product of two vectors, we have already discussed the first one, that is the dot product. Next we shall discuss the vector or cross product of two vectors. The vector product of two non-zero vectors, vector A and vector B, is denoted by vector A cross vector B and defined as vector A cross vector B is equal to modulus of vector A into modulus of vector B into sin theta into unit vector n. Here theta is the angle between vector A and vector B, and theta lies between 0 and pi, both inclusive, and n cap is a unit vector perpendicular to both vector A and vector B. If you visualize this, the figure comes like this. There are two vectors, vector A and vector B, and angle between them is theta, and their cross product is defined as vector A cross vector B is equal to modulus of vector A into modulus of vector B into sin theta into unit vector n. So unit vector n is this one. So that is perpendicular to both A and B. Means when you do the cross product of two vectors A and B, you get a resultant vector which is perpendicular to both A and B. So there are some properties we have to go through. The first one is A cross B is a vector, because here modulus of A is a scalar quantity, modulus of B also is a scalar quantity, and sin theta, when you substitute the value of theta here also will get a scalar. So all these scalars, when you multiply, you will get a scalar quantity into here is unit vector n. So when you multiply unit vector here, it becomes a vector. So A cross B is a vector. The next one is A cross B is equal to 0 vector if and only if A is parallel to B. Vector A is parallel to vector B. So vector A is parallel to vector B means A cross B must be a 0 vector. Third point is if theta is equal to pi by 2, then A cross B, vector A cross vector B is equal to modulus of vector A into modulus of vector B. Then the fourth point, this is a very important one. I cross I equal to J cross J is equal to K cross K is equal to 0 vector. Then I cross J is equal to K, J cross K is equal to I, and K cap cross I cap is equal to J cap. For remembering this one, we can use a diagram, and you have to go in cyclic order. Here I cross J, so here you can see I cross J is equal to K, then J cross K is equal to I, then K cross J is equal, K cross I is equal to J. By using this diagram, we can easily write these results. And the next one is, if you change the order here, that is J cross I is equal to minus K, then K cross J is equal to minus I, and here I cap cross K cap is equal to minus J. Then the next result is the angle between two vectors, vector A and vector B, can be calculated by using formula sin theta is equal to modulus of vector A cross B divided by modulus of vector A into modulus of vector B. And the next one, A cross B is equal to minus B cross A. That means the cross product is not commutative. When you write the dot product, we have learned that A dot B is equal to B dot A. But here A cross B is equal to minus B cross A. Next, we shall discuss point number 8. If vector A and vector B represent the adjacent sides of a triangle, then its area is given as 1 by 2 into modulus of vector A cross vector B. Here we have to note that the adjacent sides of a triangle. Vector A and vector B represent the adjacent sides of a triangle. Let's visualize the statement. Here ABC is a triangle and vector A and vector B are the adjacent sides AC and AB. Here angle between AC and AB is theta. Then area of triangle ABC is 1 by 2 into modulus of A cross B. Next, point number 9. If vector A and vector B represent the adjacent sides of a parallelogram, then its area is given by modulus of A cross B. Here also vector A and vector B represent the adjacent sides of a parallelogram. ABCD is a parallelogram and AB and AD are the adjacent sides denoted by vector B and vector A respectively, and angle between them is theta. So the area of parallelogram is given by the formula modulus of A cross B. Then next point is, if vector A, B and C are any three vectors and lambda be a scalar, then vector A cross vector B plus vector C is equal to vector A cross vector B plus vector A cross vector C. Next point is, lambda into vector A cross vector B is equal to lambda into vector A in cross vector B is equal to vector A cross lambda into vector B. Next, there is a very important result we have to by heart. Let vector A and vector B be two vectors given in component form as A1 I cap plus A2 j cap plus A3 k cap and B1 I cap plus B2 j cap plus B3 k cap respectively. Then vector A cross vector B is equal to determinant I cap, j cap, k cap, A1, A2, A3 components of the first vector, then B1, B2, B3 the components of the second vector, scalar components of the second vector. So this is the formula we will be using for calculating vector A cross vector B. So please keep it in mind. Next, we shall bring the results of dot product and cross product under one frame. In the first column we will write the dot product, and in the second column we will go for cross product. And the first point we have learned in dot product is A dot B. Vector A dot vector B is a real number. In case of cross product, vector A cross vector B is a vector. Second point we have learned vector A dot vector B is equal to vector B dot vector A, means dot product is commutative. And in case of cross product, vector A cross vector B is equal to minus vector B cross vector A. And the third point, angle between two vectors in case of dot product is vector A dot vector B divided by modulus of vector A into modulus of vector B, that is equal to cos theta. In case of cross product, angle between two vectors, that is sin theta, is equal to modulus of vector A cross B divided by modulus of vector A into modulus of vector B. And the fourth point, in case of dot product, vector A dot vector B equal to 0 if and only if vector A is perpendicular to vector B. And in case of cross product, vector A cross vector B is equal to 0 vector if and only if vector A is parallel to vector B. And fifth one is I cap dot I cap, j cap dot j cap, k cap dot k cap is equal to 1. And I cap dot j cap, j cap dot k cap and k cap dot j cap is equal to 0. In case of cross product, I cross I, j cross j, k cross k is equal to 0 vector. I cross j equal to k cap, j cap cross k cap is equal to I cap, and k cap cross I cap is equal to j cap. Next is statement number 6, that is vector A dot vector A, that is equal to modulus of A square. And sixth point in cross product is vector A cross vector A is equal to 0 vector. And some additional points we have studied in cross product, that is area of parallelogram is modulus of A cross modulus of B, and area of rhombus is equal to half of modulus of A cross modulus of B. So when you study the dot product and cross product, if you compare the results and study, we can avoid confusion. Next we shall discuss the exercise questions. Exercise number 10.4, the first question. Find modulus of vector A cross vector B if vector A is equal to I cap minus 7j cap plus 7k cap and vector B is equal to 3I cap minus 2j cap plus 2k cap. Let's take the given vectors. Vector A is equal to I cap minus 7j cap plus 7k cap and vector B is equal to 3I cap minus 2j cap plus 2k cap. We have learned the formula vector A cross vector B is equal to determinant I cap j cap k cap A1 A2 A3 B1 B2 B3. These A1 A2 A3 are the scalar components of the first vector. B1 B2 B3 are the scalar components of the second vector. So vector A cross vector B is equal to, let's calculate first row I cap j cap k cap. Next is scalar components of first vector 1 minus 7 7 it is written, and next one is 3 minus 2 2, third row it is written. Let's go for expanding the determinant. I into that row and column is gone. Minus 7 into 2, that is minus 14. Minus into minus plus 2 into 7 is 14. Minus j into that row and column is gone. 1 into 2, that is 2. Minus 3 into 7, that is 21. Plus k cap into that row and column is gone. 1 into minus 2, that is minus 2. Then 7 into 3, minus into minus plus 7 into 3 is plus 21. So here minus 4 plus 14 is, sorry, minus 14 plus 14 is 0. So that I is gone. Then next is 2 minus 21 is minus 19, minus into minus plus 19 into j, 19j. Then again minus 2 plus 21 is again 19, 19 into k cap, that is 19 k cap. Here find the modulus of A cross B. So we have to go for calculating its magnitude, that is modulus of A cross B is equal to root of x square plus y square plus z square. Here x coordinate is not there, y is there, z is there, so 19 and 19, so we will write it as 19 square plus 19 square, that is equal to root of 2 into 19 square. 119 will come out of the square root, inside the square root only root 2, so 19 root 2 is the answer. Next we shall discuss question number 2. Question is, find a unit vector perpendicular to each of the vector A plus vector B and vector A minus vector B, where vector A is equal to 3I plus 2j plus 2k and vector B is equal to I cap plus 2j cap minus 2k cap. Here we need to find a unit vector which is perpendicular to each of the vector A plus vector B and vector A minus vector B. So if we have learned in cross product, when you take the cross product of two vectors A and B, we will get a resultant vector which is perpendicular to both A and B. That is what we have learned in A cross B. So if we want to calculate a vector which is perpendicular to the given vectors, in the sense we have to take the cross product of the given vectors. Please note that we have to take the cross product of the given vectors. So let's take the given vectors as A is equal to 3I cap plus 2j cap plus 2k cap and B is equal to I cap plus 2j cap minus 2k cap. Then we have to go for finding A plus B. So vector A plus vector B is 3 plus 1, that is 4I, then 2 plus 2, that is 4j, then plus 2 minus 2, that is 0. So k cap is not there, 4I cap plus 4j cap. Then vector A minus vector B is 3 minus 1, that is 2I. Here again 2 minus 2, that is 0j cap, so j cap is not there. Then plus 2 minus minus 2, so 2 plus 2, that is 4 k cap. So A plus B and A minus B we have got. Next is we have to take the cross product. As I said before, we have to find a vector which is perpendicular to these two vectors. Means we have to take the cross product of these two vectors. So vector A plus vector B cross vector A minus vector B is equal to determinant. First row is I cap, j cap, k cap, and second row is the scalar component of the first vector, that is I coordinate is 4 and j's one is 4 and k is not there, so 4 4 0. And in the second vector if you consider, k cap is not there, sorry, j cap is not there, so second component is 0. First one is 2 and the third one is 4. So 2, 0, 4. Let's go for calculating the value, that is I into that row and column is gone. 4 into 4, 16 minus 0. 16 minus 0 is 16. Then j into row and column is gone. 4 into 4, 16 minus 2 into 0, 0. So 16 minus 0 again 16. Plus k cap into that row and column is gone. 4 into 0 is 0, minus 4 into 2 is 8. So 0 minus 8 is minus 8. So we have got the answer as 16 I cap minus 16 j cap minus 8 k cap. Then we have to go for finding a unit vector. We have got a vector, but we have to find the unit vector. For that, first of all, we have to go for calculating the magnitude of this vector. So modulus of vector a plus vector b cross vector a minus vector b is equal to root of x square plus y square plus z square, that is 16 square plus minus 16 square plus minus 8 square, that is equal to 16 square we can write as 2 square into 8 square, because 16 is 2 into 8. When square, if you take common, 2 square into 8 square. Then here minus 16 square, minus becomes plus when you square it. 16 again 2 square into 8 square plus again minus square is plus 8 square remains. So this is a short form we are using, but if you feel that convenience, which one is your convenient method, you can go with that. If you want to calculate directly, you can go for calculation, it's not a problem, but taking the common factor, it is easy, that's why we have taken. That is equal to, here everywhere 8 square is common inside the square root. If you take it outside the square root, it comes as 8, and the remaining things are 2 square, here 1 2 square, here 1. So that is equal to 8 into 2 square is 4, again 2 square is 4, again plus 1. So 4 plus 4, 8 plus 1, that is a root of 9. Root of 9 is 3, so 8 into 3 is equal to 24. That is the magnitude. Next, we have to calculate the unit vector. We have already learned the formula for finding the unit vector. Unit vector calculation is, we have to divide the vector by its modulus. Then we will get the unit vector. So unit vector is plus or minus vector a plus vector b cross vector a minus vector b. This is the vector we have already calculated, which is perpendicular, divided by modulus of that particular vector, that is vector a plus vector b cross vector a minus vector b. Here how plus or minus comes, that is a question. We have already learned in while studying the vector or cross product. A and b are any two vectors and theta is the angle between these two vectors. Then a cross b is modulus of a into modulus of b into sine theta into vector n, means that particular vector a cross b is perpendicular to both a and b. So here if it goes upside, it is positive unit vector n, and if it comes downside, then it is negative. So that's why we included here both plus or minus. That is equal to, we have already calculated this value, that is 16 I cap minus 16 j cap minus 8 k cap divided by modulus value we have already got 24. So here when you look at the numerator, there is an 8 common. We can take out 8, or we can cancel 8 from the numerator and from the denominator. When you cancel 8, the denominator will become 3. Numerator is 2i minus 2j minus, here 8 is gone, 1k or k cap divided by 3. So we have to split the denominator equally, that is plus or minus 2 by 3 I cap. Again here minus and plus or minus together, so the order will change, that is minus or plus 2 by 3 into j cap. Again here minus is there, when it comes with this one, the order of this plus or minus will change, that is minus or plus 1 by 3 of k cap. So this is the required vector. Next we shall discuss question number 3. The question is, if a unit vector A makes an angle pi by 3 with I cap, pi by 4 with j cap, and an acute angle theta with k cap, then find theta and hence the components of vector A. Here the unit vector A cap have components A1, A2 and A3. Let the components be A1, A2 and A3. And let the vector be vector A is equal to a1i plus a2j plus a3k. Here one more condition is given to us, that is unit vector, that is modulus of vector A is 1, magnitude of that particular vector is 1. Since here the angles are given to us, we have to go for direction cosine formula. So we have already learned L is equal to x by r, m is equal to y by r, and n is equal to z by r. L, m and n are the direction cosines. L means cos theta, m means cos beta, and n is cos gamma. We have already learned this one. By using that formula, L is equal to x by r, that is cos theta. Cos, first one is theta is pi by 3. So cos pi by 3 is equal to x by r. X means the x component and r is the modulus of that particular vector. So here x component is a1 and the modulus of that vector is modulus of a itself. That is cos pi by 3, we know it is 1 by 2, that is equal to a1 divided by modulus of a value is 1. So a1 by a is a1 itself. So a1 is 1 by 2. Next is m is equal to y by r. M in the sense cos beta. Cos beta, beta is pi by 4 here. So cos pi by 4 is equal to a2. Y component is a2 by modulus of a. So cos pi by 4 value is 1 by root 2 is equal to a2 by 1 is a2. Next one is cos theta. We don't know the value of theta. So cos theta is equal to a3 by modulus of a. Modulus of a is 1. Therefore a3 is equal to cos theta. Let's take again the given condition. Modulus of a is equal to 1. That is root of x square plus y square plus z square. X, y, z are a1, a2 and a3 respectively. So root of a1 square plus a2 square plus a3 square is equal to 1. When you are squaring, we will get as a1 square plus a2 square plus a3 square is 1. Square root is gone. Let's substitute the values. That is, we have a1. a1 is 1 by 2, that is 1 by 2 the whole square. a2 is 1 by root 2. So when you square it, 1 by root 2 the whole square plus a3, same cos theta is equal to 1. Go for the calculation. That is 1 by 4 plus 1 by root 2 the whole square is 1 by 2 plus cos square theta is equal to 1. That is, here 1 by 4 plus 1 by 2, when you do the calculation, it will come as 3 by 4 plus cos square theta is equal to 1. Then cos square theta is equal to 1 minus 3 by 4, that is 4 minus 3. 4 minus 3 is 1, that is 1 by 4 is cos square theta. Then cos theta is equal to 1 by 2 we will get. Then theta is equal to pi by 3. Theta is pi by 3 in the sense theta is 60. So theta we have got pi by 3. The first part is over. Next we have to go for find the components of vector A. Here a3 we can calculate, that is cos theta. Cos theta in the sense cos theta is pi by 3. So cos pi by 3, that is equal to 1 by 2. So a3 also we have got 1 by 2. Then we have to go for writing the components of A. That is components of A are, this is a1, a2, a3 are the components. a1 already we have calculated, that is 1 by 2. a2 we have calculated 1 by root 2, and a3 is cos theta. Cos theta we have already calculated, that is cos pi by 3. Cos pi by 3 is 1 by 2. So 1 by 2, 1 by root 2 and 1 by 2 are the components. Next we shall discuss question number 4. The question is, show that vector A minus vector B cross vector A plus vector B is equal to 2 into vector A cross B. It's a very simple question. Let's take the left hand side, that is vector A minus vector B cross vector A plus vector B is equal to, just multiply or take the cross product first one with the first vector, that is vector A minus vector B cross A, that is written. Then again the first bracket with the second vector, that is vector A minus vector B cross vector B. Then using the distributive property, just we can expand it again, that is vector A cross vector A minus vector B cross vector A plus vector A cross vector B minus vector B cross vector B. Here we have to use the properties. We have already learned vector A cross vector A is 0 vector, vector B cross vector B is also 0, and minus B cross A we can write it as A cross B. So A cross B is equal to minus B cross A. So this minus B cross A we can change as A cross B. These three results we can apply. The first one is 0 vector, then minus B cross A we can write it as plus A cross B. This one we can keep as it is, that is plus A cross B minus B cross B is 0 vector. Here A cross B plus A cross B, that is 2A cross B. That is the result we need to prove. Next we shall discuss question number 5. The question is find lambda and mu if 2I cap plus 6J cap plus 27K cap cross I cap plus lambda J cap plus mu K cap is equal to 0 vector. Let's take the given statement, that is 2I cap plus 6J cap plus 27K cap cross I cap plus lambda J cap plus mu K cap is equal to 0 vector. Since the vectors are in component form, we can use the determinant method, that is I cap, J cap, K cap, first row, and first vector components we can write it as second row, that is 2, 6 and 27 comes as second row, and 1 lambda mu comes as third row is equal to 0 vector, we can write it as 0 I plus 0 J plus 0 K cap. Let's expand it. I cap into row column is gone, 6 into mu, that is 6 mu, minus 27 into lambda, 27 lambda, minus J cap into that particular row and column is gone, 2 into mu, that is 2 mu, minus 1 into 27 is 27, plus K cap into that row and column is gone, 2 into lambda, that is 2 lambda, minus 1 into 6 is 6, equal to right hand side is as it is 0 I cap plus 0 J cap plus 0 K cap. Then let's equate the components, that is here 6 mu minus 27 lambda, no need to take because two variables are here, so it is very difficult to find out two at a time. So here it's okay, fine, 2 mu minus 27, only mu we need to, unknown quantity is there, and here all this also no problem, 2 lambda minus 6, only lambda is unknown. So let's take 2 lambda minus 6 first. 2 lambda minus 6 is K component here is 0, equal to 0. From here lambda is equal to 6 will come on the right side, 6 by 2 is 3. Next is 6 mu minus 27 lambda, this one you can take, or this also is not a problem, anyone. Here I am taking this one, 6 mu minus 27 lambda is equal to 0, because now we have got the value of lambda, so this equation also not a problem. 6 mu minus 27 lambda equal to 0, just substitute it, 6 mu minus 27 into 3 equal to 0, lambda value is 3. Then 6 mu is equal to minus 27 into 3 when goes to the right side, plus 27 into 3. From here mu is equal to 3 and 6 can be cancelled 2 times, so 27 by 2 is the answer. So here we have got lambda as 3 and mu as 27 by 2. My dear students, today we have learned the cross product of two vectors and its properties, and also we have combined the results of dot product and cross product. We have solved some questions from exercise 10.4 by using the dot product properties. Hope it is clear for you all. While practicing, please compare the dot product and cross product and recall all the basic concepts. And while practicing, if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.